Chapter 5 of Statistics, entitled Statistics and Research of Interactive Statistics Methods, begins with describing statistics in terms of a graphical representation. This is critical. This is where you're going to find the pages in the book, such as page 88, that really goes into detail describing to you the relationship, the unique relationship between statistics and research. So most of this, or the vast majority of this chapter, is represented in graphical form because it's easier to visualize those relationships using the graphs that are presented. So let's take a look at some of those. So here's a model which illustrates the statistical terminology in terms of a model showing the integral relationship between research and statistics. Again, this is the one that's on page 88. So you have your research hypothesis, which splits into the population parameters and the sampling derived out of that. All right, and you'll notice that statistics, or the method of analyzing data, falls later in the process. So statistics as a science, as a means of representing and deriving numerical data, is only a part of the vast, larger structure that is research design. So you really need to know what your educated guess is in your hypothesis. Who is the population that you're going to study? All right, how you're going to derive the sample out of that population, because it is the expectation of the researcher that once they derive and are able to either reject or accept a hypothesis based upon the data acquired from that sample, that the sample being representative of every member of the population, meaning every member of the population had an equal chance of being in the sample, you're going to be able to take this data, analyze it, make an assumption based upon supportive research that shows that some statement regarding your educated guess applies to the sample, and you want to be able to infer or apply that back to the population. And your ability to do that is based upon the sample really being representative of the population. And we break down statistics further. We have descriptive statistics, descriptive, key term, describe, and inferential statistics, meaning to infer and question and go deeper into. And in those two branches, we have two branches in inferential: parametric, meaning a normal curve, normality. We'll talk about that a little bit later. And non-parametric measures, which basically means non-normal curve. And the basic measure we're going to look at that is chi-square. So these are various methods of looking at data. Remembering our scale of measurement being nominal, ordinal, interval, and ratio. And based upon what that is, there are different statistical measures that apply to our research design about our initial research question, which is our hypothesis, that we derive and analyze data from the sample to go back to that hypothesis, population, based upon our ability to provide support for or against a null hypothesis, or the opposite effect. And we're going to talk about that when we get into research design, and a bit later really talking about hypothesis testing. And that's what we're building to. So there is another model or map here that tells you types of research design. There's another on statistical data analysis methods, and it tells you, based upon whether you're looking at inferential or descriptive statistics, what are the ways in which you can analyze that data and how it breaks down. So studying these in depth will show you and bring you down to the various measures that we use, such as ANOVA, analysis of variance, t-test of independent means, where your measures of center are, measures of prediction, how those apply in the statistics data analysis methods model. That's what can be found on page 91. The actual process in terms of research design can be found in the subsequent model that follows after the previous model that we just talked about. And it shows you how you select your data analysis method, generate your mathematical hypotheses from your initial research questions, and then the research hypotheses and the mathematical, to actually begin the calculations for stat to determine whether the null hypothesis is true or false. Data gathering methods, all of these pieces are integral parts down to reporting your final research of the entire research design. So understanding this chapter determining the relationship, which we really talked about, between statistics and research. And then there's a long litany in here of different ways to display data graphically once you've actually acquired the data. So you want to look at that. How do you build the graph of the data? There's a table on that shows you that. And then it goes in depth into the parts of the graph. More terms, you need to know them, that'll help you. And then the graphs themselves, line graphs, bar graphs, histograms, frequency polygons. There's a virtual plethora of ways in which data can be represented. So you want to take a look at this chapter, look at these, because you're going to see a lot of this. You might not realize that you see some of this during the time in which we're voting, or different surveys determine how much persons in marketing determining whether a product is liked or not liked, or whether persons will buy it. Statistics is used in all of these different areas. You're going to see different histograms showing you the measures of central tendency, mean, mode, median. Those three, when they're alike, when they're different, what the three of those mean. And then going down into more plots. Which way you can think about plotting data, pretty much, if it hasn't been done, there's probably someone who's dealing with it. So all kinds of graphs, graphing of data, because that becomes a way of actually displaying data. Very important. Data display is critical to statistics, whether inferential or descriptive. The ability to visually display data, because laypersons who don't really know the science are better able to understand what you're saying. And then a lot of times when you have a lot of narrative, it's easier to represent that data graphically. Finally, coming to the main point of inferential statistics, which we refer to as the normal bell-shaped curve, named after the great mathematician Gauss, who really used this principle in his mathematical calculations. So it's known as the Gaussian distribution. And we're going to talk about that in detail. So once you go there and you understand basic things, we're then able to move into what are the symbols used in statistics. And in statistics, we use lowercase Greek to indicate the population parameters, and this table shows that. And we use lowercase Roman letters that we use in our traditional writing to indicate a sample. They mean the same thing, it's just the magnitude or size is different. And of course, we know the sample should reflect the population because it's extracted out of that. So we're beginning to understand the language of statistics and how these things are used. The three main measures of central tendency: the mean, the arithmetic average, the median, the middle score, and the exact middle when you have organized your data, and the mode, the most frequently occurring score, what occurs again and again. And that's discussed in detail. All right, and then there's a graph even in here of how you identify data. So all of that will help you, going back to our skills of measurement and understanding that, and ending with the scale, and then presenting what the scale name is, what it means, and then an example of that scale, which we used earlier on page 120. It ends with talking about percentages and quartiles and what they actually mean when you rank your data, organize your data, whether 25% point, 50th percent point, or 75th, those are the quartiles. And then P of 1 through 100 representing the various percentages of your data. So you're going to see things like box and whisker plots, things of that nature, which will better help you to identify data. And there's even a chart I placed in here so you can identify data variation. So go through this, look at the sample data sets, how data is tallied, how things are organized, your methodology, everything that you need to know about getting percentages and how to represent data graphically is covered in chapter 5. So read it thoroughly. Take a look at the techniques. If you have any questions, you can always ask me. And then once you understand that, and it ends with talking about Dr. J.C. Liu's percentile algorithm and what the index of qualitative variation is, that'll give you a better understanding of how to apply and begin to take numbers when you derive them as data and tally them, and how percentages, cumulative percentages, all of that is derived. So if you follow the tables in the chart and you follow the narrative, it's going to guide you through this process. None of it should really be confusing. Okay, so chapter 5 is long because there's a lot of ways to graphically display data. So read it thoroughly, and you should be ready to move to the next chapter as we begin to calculate with data.